Today we are going to discuss an interesting topic in electromagnetism, and that topic is electromagnetic induction. It has a wider application, huge application in generator, alternator, tape recording, applications in transformer, application in computer memory, etc. That we can discuss later on after completing the exercise at the end of the sections. It was first introduced by Michael Faraday. Michael Faraday. So it is known as Faraday's law. Faraday's law. As you know that producing magnetism using a magnet is called magnetic induction. The space surrounding the magnet is called magnetic field. So if I consider this is as a magnet, so the space surrounding the magnet is known as magnetic field. So this is my magnetic field right now. To quantify the magnetic field, we need flux, and we know that in a magnet, lines of forces pass from north to south and they do not intersect each other. They do not intersect each other. So, if we consider a magnet, and if we draw the lines of magnetic lines of forces, if we consider area like this, then magnetic flux is defined as the number of lines of forces passing through this particular area. Magnetic flux denoted by phi. Mathematically, we write this is a dot product of B dot A. So phi we have B dot A. Remember, it's very important. Phi is B dot A. If we break the dot product, we can write as cos theta. What is theta? Theta is the angle between the magnetic field and the area vector. It is the angle between magnetic field and the area vector that we will discuss right now. Now, what is the unit of phi? As we know that phi is B into A if theta is 0 degree and cos 0 value is 1. This is Tesla and it is area. So Tesla meter square. Tesla meter square is known as Tesla meter square is known as Weber, WB. This is the SI unit. It is the SI unit. Now come to this part. Look at this one. This is magnetic flux. I have done three cases I have taken. if I look at this diagram where this is the particular area of area vector A and this is my magnetic field. So the angle between them, theta, is nothing but 0 degree. Why? Because B is parallel to A. So in that case, we know that phi is BA cos 0 degree. We know that cos 0 is 1, so phi is BA. How this is happening? If I take this one, look at this. If I consider this is a surface, and this surface has a direction that is perpendicular to the plane of the paper. If we rotate the surface, if I take the surface like this, direction will be in that direction. If I take the surface like this way, direction will be in that direction. And we know that area is a vector quantity. Area is a vector quantity. And this part, this is the magnetic field and this is my area. This is the whole thing is the area. Here the area vector is perpendicular to the magnetic field. Area vector is perpendicular to B. That means theta is 90 degree. So phi is BA cos 90. And we know that cos 90 is 0. Cos 90 is 0. So here flux is 0. Flux is 0. Look at this part. This is very interesting. If I am saying this is my surface, lines of forces are passing in this direction, in this direction. If I consider the surface of this portion, so its direction is perpendicular to the surface, which is anti-parallel to the magnetic field. Like this, it is anti-parallel to the magnetic field. So B direction, in this direction A, angle between them is 180 degree, theta 180. In that case, flux phi is BA cos 180. Cos 180 is minus 1. So this is BA because cos 180 degree is minus 1. Next, come to the magnetic flux density. Look at the formula. Phi is B is phi by A. How this is coming? As we know that phi equal to B into A. So from here we can write B equal to phi by A. If A is 1, suppose meter square, then B is phi. That means the flux through unit area, flux through unit area is known as magnetic flux density. Magnetic flux density. What will be the unit? The unit, look at this one. B is phi by A. We know that B is phi by A. Now what is the unit of B? B unit is Weber and area is meter square. So we can write Weber per meter square. This is nothing but Tesla or T. Got it? So magnetic flux density is nothing but phi by A. If you take area as 1 meter square, then only you can say the magnetic flux density is nothing but the flux. The flux density, unit area, flux through unit area is known as magnetic flux density. And in units, Weber per meter square, which is known as Tesla.